Okay, on lesson 5, this is actually 5. Okay, 5.4a, because we're splitting this up. Okay, we're going to look at normal distribution and standard deviation. Okay, so let me start reading this. We'll start filling some of this stuff in. Okay, one special type of distribution of data is called the normal distribution, or the normal model. Okay, the normal model is often thought of as this shape right there. What is this shape? Bell curve. So, bell curve. Okay. A bell curve happens when the data is, and we don't have to memorize this word, but it's unimodal. Unimodal. Okay, single peaked. Okay, and the distribution on each side of the peak is symmetrical. So it's the same on both sides. Oh, okay, thank you. Okay, is on each side of the peak is symmetrical. Symmetrical. Okay. Okay, you all know what a bell curve looks like, assuming, I guess. There's our bell curve right there. It's even on both sides. Okay, when a distribution of data is deemed to fit a normal model, the standard deviation is used to break up the model into defined sections. So the standard deviation. Okay, so we're going to use that standard deviation that we learned. Okay, it's used to break this model into defined sections. Okay, the sections are represented below. The center is labeled as the average or the mean of the data and has a standardized score of, and we're going to put 0 right there, due to the fact that it's 0 standard deviations from the mean, because the mean is 0, if they're just using this here. So let's go ahead and fill out this little bell curve here using our standard deviation. So in the middle, we're going to put 0 in this case. And then this breaks down into, well, 1 standard deviation away, 2 standard deviations, 3 standards. So let's go ahead and break this into, try to draw this evenly, but that's 1, 2, and then 3, put about there. So try to draw it just like I have it. And then on the other side, evenly spaced. Here's 1, 2, and 3. 1, 2, and 3. Okay, I didn't put -1, -2, -3. You can, but this just breaks up the model into defined sections. Okay, then draw straight lines down and break this up, just like this. And this right there, there, and there. Okay, now we're going to figure out some percentages. Okay, get caught up there. Okay, so the breakdown of this normal model, and these percentages you have to memorize. Okay, that we're going to put right in here because you're going to have to fill these out. Okay, if you're within 1 standard deviation either way of 0, so this way or this way, this amount of data right there, if it's a normal distribution, it's 68% of all your numbers in your set or your sample lie within 1 standard deviation from the average. So 68%. All right, so 68%. So what is in each one of these little columns? 34. So 34%, so write this in. So these are the percentages you have to memorize. So 34 there and 34% there. Okay? So 34, or actually 68% lies within 1 standard deviation. Okay, within 2 standard deviations, okay, 95% of all the data lies within 2 standard deviations of the average. So there's 1 standard deviation, and there's 2. So 95% of all your numbers lie right in there. So we need to come up with those percentages. So what would we put in those 2 blank spots there? Or how would we figure that out? Okay, 95 minus 68. Good. And then divide it by 2. So 95 minus 68, help me out, what is that? 27. So 27% makes up those two, so let's go ahead and divide that by 2. 13.5. Okay, so write that in. 13.5%. 13.5%. Okay, we've got to memorize those. And when you use these a few times, you'll just kind of memorize them. Okay, and then within 3 standard deviations of what is normal, plus or minus 3 standard deviations, just about everything lies within 3 standard deviations. So 99.7% lies within 3 standard deviations. Okay, so how do we figure out the rest of that? 99.7 minus that 99 we have already. So what is that? 4.7. 4.7. And what's 4.7 divided by 2? 2.35. Good. 2.35%. 2.35%. Okay. And let's go ahead and put the rest because there is stuff there. Well, if it's 100%, but that's 99.7% of everything is right there, then that's 0.3% left, right? So then divide by 2 is 0.15. So actually, let's put it here, 0.15%. 0.15% is the rest on the outside. Okay. Okay, it says use these breakdowns to complete the model. So there it is. Okay, memorize these numbers: 34, 13.5, 2.35, and 0.15. Okay. All right. So example 1: traffic studies have shown that the vehicle speeds on a certain portion of a freeway when there are no accidents or construction delays, so just flowing along, whatever, on this certain section of a freeway, follow a normal model with the average speed of 67 miles per hour. Okay, and a standard deviation of 4 miles per hour. So the normal, okay, and that's a Greek letter mu, I guess, is 67. So the average is 67 with a standard deviation of 4 miles per hour. All right. So task number 1, represent this information with a normal model. Indicate speeds within 1, 2, and 3 standard deviations of the mean. You'll use this graph to answer the next set of questions. Okay, so here's our bell curve. All right, so what was the average speed on this section of the freeway? Okay, so put that right there, 67 miles per hour. Okay, then we break this down and we'll kind of this model up there. So 1, 2, 3 standard deviations. So draw this like this. Okay, 1, 2, 3. So it should be symmetrical on both sides, like that. Okay, and then we'll put the percentages in. 34%, 13.5, which we are going to memorize. 13.5, 2.35, 2.35%, 0.15, 0.15. Fill all that out. So if you memorize those values, and we can fill out the bottom, these problems are pretty easy. Okay. All right, so it says the average speed on this freeway is 67 miles per hour. What was the standard deviation? 4 miles per hour. Okay, so let's fill out the numbers on the bottom. So if that's 67 miles per hour, what is the next one over? 71 miles per hour. How did we get that? We added 4. And then add another 4, 75 miles per hour. And then add 4 again, 79 miles per hour. Okay, and if you're going higher than that, 80 miles per hour, then these small amount of cars go that fast, right? Okay, and then subtract 4. So that's 63 miles per hour. So not all cars go the same speed, right? Some are in the slower lane, some are faster, whatever. Okay, and then what is this? 59, and this is 55, some are going real slow, pulling a whatever, or 95-year-old is kind of putting along there. Question? Oh, you good? Okay. All right. So let's look at these questions. Okay, what percent of all vehicles travel over 71 miles per hour? What percent travels over 71 miles per hour? So, well, all of these cars, because they could be going 80 miles per hour, right? Even 95, possibly. Okay, well, how do we figure out the answer? Just add those up. Okay, so 13.5 plus, by the way, 2.35 and 0.15 adds up to 2.5. 2.5. So what percent? 16%. Okay, so 16% of all the cars on that freeway, not a whole lot, but 16% travel over 71 miles per hour. Okay, B, what percent travel between 63 and 75 miles per hour? 63 and 75. So we just add those up. So 68 plus 13.5. 68 plus 13.5? 81.5. So 81.5% of all those cars, quite a few, travel between 63 miles per hour and 75. Okay. How many, what percent of all the vehicles travel less than 67%? Less than 67%. This should take half a second to 50%. This adds up, that's half of them, right? So 50% travel slower than 67 miles per hour. Okay, what about between 55 and 63 miles per hour? What is that? 15.85%, right? Just add those up. So 15.85%. Pretty easy? Good. Okay, faster than 63%? What do we add?
You add 34 to 50.
Yeah, add 34 to 50, right? Does that make sense? So 84%. Okay, so 84%. So there we go. Less than 59 miles per hour? 2. That adds up to 2.5. So 2.5, so most are going at least 59. Okay, the middle 95% of all vehicles travel between what speed and what speed? Where's 95% of all the, is that 95% right there? So yeah, so between 59 and 75 miles per hour. So 59, 59, and 75. Okay? Okay, so there's other problems that we need to know how to do. So get your packets and open to the homework on 5.4. So there are other problems that we didn't cover on those notes that we need to know. Okay, so number 1, I'll let you guys do that. You can figure that out. Well, let's look at number 2. Okay. So it says 1,800 students at Cal State University took a biology exam. Okay, the scores were distributed normally with a mean, so an average of 70, and a standard deviation of 5. Okay, so the average score on this biology exam was 70%. Okay, label the mean and the 3 standard deviations from the mean. Okay, so let's fill out the chart again. Okay, or the bell curve. So what goes right there?
75.
What goes right there?
70.
70. 70 was the average score. How many took the test, by the way? 1,800 students took this biology test. That's a lot of students. Okay, so that's the middle. So we do that. So 70 is the average. What was the standard deviation? 5. Okay, so can we put these here? So what goes right there? 75% on the test. 80%. I'll put 85 up there. It goes higher. I guess not a lot of people got whatever. Okay, then go 5 this way. So 60, 65, 60%, 55. Right. Okay, and then draw the sections there. This. Okay, let's put in the percentages. Again, if you could put the percentages in, put the standard deviations, these problems will be easy. So what percent goes right here? 34%. What goes right there? 13.5. I'm going to draw an arrow to it. What goes right there? 2.35. And then it's a 34, 13.5, 2.35. There we go. Okay, so it must have been a pretty tough biology exam because 97.5 or whatever score between. Okay, I know we can answer these because that's what we just did on our notes. For example, what percent of scores are between 65 and 75? 68%, right? Okay, well, let's skip down to F. Okay, on F. Okay, it says approximately how many biology students, not percent, but how many biology students scored between a 60 and a 70%? Well, there you go. So there's 1,800 students. So scored between 60 and 70. Okay, this is 47.5%. So it's 1,800 times 0.475, and that gives you 855 students. There you go.